Hi guys, you are welcome once again to the Smart Way lectures on the Science Ambassador series. This is a series of lectures we are bringing to you on all the areas in science. And today we are going to continue our calculations on how to find for the number of a double bond and the number of a triple bond within a particular compound. Now, this is all informed when you can know the number of hydrogen gas that are consumed in the reaction. The number of hydrogen gas consumed in the reaction can be used to find for the number of double bonds that are there. So in our previous lecture, we told you that every single double bond, okay, every single double bond, that is every one double bond, okay, can be converted to every one double bond can be converted to a single bond. Okay, it can be converted to a single bond by what? One hydrogen gas or two hydrogen atoms, okay, or two hydrogen atoms. So we have said that, and we did that by giving you the fact that if I have a double bond, one double bond within a compound like this, okay, if I have one double bond within a compound like this, okay, okay, there is only one double bond here. This is the double bond here, okay, it's only one. Now if I want to convert this one to a single bond, meaning that I'm going to place this double bond, okay, with two hydrogen atoms. Okay, two hydrogen atoms is coming to one hydrogen atom will sit here, the other hydrogen atom will sit here, and that will clear out the what? This double bond there. So we are going to get this. So in our last lectures we looked at this. Okay, this is just a quick one I'm doing before I solve the questions. Okay, so this time we have moved the double bond by introducing two hydrogens. Okay, so that is it. So that is two hydrogen gas has come to occupy this one. Okay, now two hydrogen atoms equivalent to what? One hydrogen molecule. Okay, 1 mole of hydrogen molecule, so it's the same. So basically that is it. So it depends. So if you have, it depends. So you can go on. If you have two double bonds within a particular compound, then you should expect that you require how many? That is two atoms here, another two atoms here. That was 4 hydrogen atoms. You require 4 hydrogen atoms in all, which is equivalent to one what? Which equivalent to 2 what? Hydrogen what? That is 4 hydrogen atoms supposed to be here. Okay, so 4 hydrogen atoms. So 4 hydrogen atoms here. Okay, so 4 hydrogen atoms. 4 hydrogen atoms here. In that case, we are going to get 2 here. And when you draw it, you will see that you have this, and this, and this space, this one, okay, this one and this one will go, and so you will see that we will have that space occupied by here, okay, and that will also be occupied by this place too. Okay, so here we have 4 hydrogen atoms able to clear two double bonds. Okay, 2. So here how many double bonds are here? 2. So we have that. So basically that is what we talk about. So to remove a double bond, a double bond, one double bond, you always have to convert one double bond to what? A single bond. You always have to use what? 2 hydrogens. So if it is 2, then it's 4. So and so on and so forth. So you can go on. And we also talk about the triple bonds. Okay, so triple bonds. In that case, if I want to clear out all these triple bonds to a single bond, Okay, if I want to clear out all these triple bonds to a single bond, what do? Okay, now so here what it means is that I have to add, okay, hydrogen here, okay, hydrogen here, in order to clear out this double bond and that double bond there. Okay, so in that case I'm going to get this. Okay, I'm going to get this, and then the new hydrogens that will come and remove the double bond to be this. Okay, so for triple bonds, for if we want to convert one triple bond, okay, if we want to convert one triple bond to a single bond, if you want to convert triple bond to a single bond, how many do you require? You require 4 hydrogen atoms. You require 4 hydrogen atoms in all. That is equivalent to two hydrogen molecules. Okay, two hydrogen molecules. Okay, so basically we talked about this. Extensively. Okay, we talked about this extensively. We are going to use this question to further expose the answer. Okay, to further expose the concept. Okay, so the goal. So let's continue. So we are going to solve this question now quickly. It says that 18.3 milligrams of an unsaturated hydrocarbon consumes a certain volume of what hydrogen at STP on catalytic hydrogenation. If the molecular mass of the hydrocarbon is 80, to calculate the molecular formula of the compound. Here calculate the maximum number of double bond per molecule of the compound. If the molecule is an alkane, that is, if the molecule is a double bond. Okay, so an alkane, we'll talk about this. Here it's a double bond. Okay, if it's a double bond. Okay, and here if it is a triple bond. Okay, a triple bond. Okay, so we'll talk about this in our next video. We are going to classify all organic compounds. So how many double bonds are there? This one is just a word. How many double bonds are there? So quickly, there is a triple bond. So how many double bonds are there? Let's solve the question. In the first one, so let's write the data as chemists always do. We always have to write data to follow. So here we have mass of the unsaturated hydrocarbon. So here mass of unsaturated, so mass of unsaturated hydrocarbon. So let me just write C is equal to what? 18.3 grams. That is 18.3 milligrams. And then it says that it consumed this cm cube. That means volume of hydrogen gas consumed. Very important. That information is very important. Volume of hydrogen gas consumed. Okay. Consumed. Volume of hydrogen gas consumed is equal to 10. Okay, it's equal to 10 what? Cm cube. It's equal to 10 cm cube. And it says that the molecular mass of the hydrocarbon. Yeah, the molecular mass of the hydrocarbon is also given to us. Molecular mass. This one is normally gotten from mass spectrometer. You put the molecule in the mass spectrometer, and then the mass will come out, and this is the answer. This is the mass. So this one is very simple. So molecular mass of the hydrocarbon. You also have to write it. See how I'm writing my information. Before I begin, I know everything. So once I do that, then I begin to carry the information and then use my theory to solve it. Here it says how many double bonds are there. Now in the theory it says that if you are able to know the number of what, if you are able to know the molecule or the number of hydrogen, okay, that are consumed, you can relate the number of hydrogen to the number of what double bond consumed, and you can also relate to the triple bond consumed. So we are going to do that. So quickly, let's find for the mole of the hydrogen consumed. Okay, Let's find for the mole of hydrogen consumed. Quickly, how do you do that? First, let's calculate for the volume. Any calculation will work. Let's calculate for the volume, or let's calculate for the mole. Good. In chemical reactions, it's mole that normally consumed. So let's calculate for the mole of what? Hydrogen. Mole of hydrogen gas consumed. Now, mole of hydrogen gas consumed, the formula is because it's at STP, that is at standard temperature and pressure. Remember the conditions. So please, let's put the conditions down. The condition is very important. So the condition is that it is at what? STMP. So at STP, if you want to find the volume, if you want to find the mole of a certain gas at STP, the volume you use is the volume over what? The molar volume. Okay, you use the molar volume. So mole of the hydrogen gas is the volume over the molar volume. And in the question, they've given us the volume, and the volume is what? 10 what? cm3. The volume is 10 cm3. And so you divide by the molar volume. The molar volume of Vm is supposed to be 22.4 dm3. Okay, 22.4 dm3, or it can also be 20 what? That is 2200 and what? So it can also be this. Okay, it can also be that. It can also be that. Okay, so you just multiply here by 1000 and then you attach some 2 zeros to it, and then that is all. So then you are going to get, this one can be in cm3. So let's use cm3. So we are going to use this molar volume in cm3. Okay, top and down cm3. You can also use top and down dm3. I preferred mine cm3 like this. So here, the volume you are going to get here, after doing your calculation, you will get a certain volume, and the volume you are going to get here is this. We are going to get the mole we are going to get is 4.46 times 10 raised to the power negative what? 4. Negative 4 moles. Okay, negative 4 moles. Okay, so this is the volume of that. This is the volume of hydrogen that was consumed. Now this is the mole of the hydrogen that was consumed. Let's find for the mole of, okay, let me use that different color there. Let's find for the mole of the hydrocarbon that was consumed. Okay, mole of unsaturated hydrocarbon. Remember that the reason why we are finding for mole is that in chemical reaction is the mole that normally react. We don't usually use mass. We don't usually calculate amount in terms of mass in reactions. It's mole, because that mole contains the same number of Avogadro's constants, so it is always preferred. So mole of the hydrocarbon, mole of the unsaturated hydrocarbon, and the mole of the unsaturated hydrocarbon is the same as this one. Is not at STP. Okay, so we are going to get mass over what? Molar mass. That is a mole concept. You use the mass over the molar mass and you get it. Okay, so this compound was not at STP. It was the hydrogen that was consumed at STP. So quickly, and because it is a solid, we don't usually use this one. If it is a gas, then we can use that. Okay, so remember at STP we use them for calculating volumes. Okay, volume. So we don't use for the solid. For the solid, you can use this formula. Okay, so quickly you do that. Now let's quickly divide. Okay, let's quickly divide. What was the mass? The mass is 18.3 milligrams. And then it's 3 milligrams. Please, the molar mass 13.3 milligrams. So divided by this milligram. So but remember we have to work in what? In grams. So if you want to convert milligrams to gram, you just multiply by 1000. That's divided by this 1000, or multiply times 10 to the power negative 3. In that case, we've converted it to what? Grams. And then this 82, we already know that molar mass are always in gram per what? Gram per mole. So I didn't put it here, but you should know that molar mass are in gram per what? Per mole. Good. So when you do that, we are going to get 2 point what? And do that, we are going to get 2 point what? 2.23 times 10 raised to the power also negative 4. Okay, so you are going to get that in moles. So 2.23 times 10 raised to the power negative 4. Now that you know the mole of the unsaturated hydrocarbon, okay, the mole that was consumed, you can now find for the number of hydrogens that are inside. How do we find the number? I told you by mathematics. Number okay, of triple, the number of double or triple bond. Okay, number of triple or double what? Bond. Okay, within the compound is proportional to the mole of hydrogen consumed. Okay, mole of what? Hydrogen, okay, consumed. Okay, so if you know that, then you can know that, okay, if you know the mole of hydrogen consumed, the mole of hydrogen consumed. So what do we do here? Or what you do is that to find for the number, you know the mole of the hydrogen gas consumed already, and you know the mass, the mole of hydrocarbon that has consumed. So by dividing the mole of hydrogen, okay, consumed, mole of what? Hydrogen consumed, by dividing the mole of hydrogen consumed, okay, by dividing for the mole of hydrogen consumed, okay, divided by the mole of what? The mole of the unsaturated hydrocarbon, by dividing that unsaturated what? Hydrocarbon. By doing that, you will get the number of what? You will get the number of what? Triple or double bond that are there. So that is the trick, because number is proportional to volume of hydrogen consumed. So if you want to find the number of hydrogen consumed, you just divide by the mole of the whole compound, and then you will know that. So because remember, it is the mass, it is the hydrocarbon that, okay, has reacted and consumed this. So you can strike the ratio and then you know that. So let's do the ratio. When you do the ratio, you are going to get, let me change the color. So if you do the ratio, you are going to get 4, okay, that is it here, this one, 4.46 times 10 raised to the power what? Negative 4 mole, divided by the mole of the unsaturated what? Hydrocarbon, that is 2.3 times 10 raised to the power this 4. So here we are going to get the final answer to be 2:1. Okay, we are going to get the final answer to be 2:1. So here you can get, this is the mole of the hydrogen consumed. That is this is the mole of the hydrogen consumed. So we have 2 moles of hydrogen gas consumed, okay, per 1. Okay, that means that 1 molecule of this, 1 molecule of the hydrocarbon, okay, that means that that means that this one molecule, okay, of the unsaturated hydrocarbon, the 1 molecule of the unsaturated what? Of the unsaturated what? Hydrocarbon, okay, it's responsible for 2 hydrogen, okay, it's responsible for 2 hydrogen, okay, 2 mole of what? 2 mole of hydrogen. In that case, we now know that we have 2 hydrogen gas that was consumed, so 2 moles of hydrogen gas was consumed. So here it means that we have 2 moles of hydrogen gas consumed per every 1 mole of here. And now what did we say about the connection? What did we say about the connection? We said that the connection is that one, okay, double bond, okay, is consumed by to convert 1 double bond to a single bond, okay, you need 1 hydrogen what? Gas. And to do 2, you need what? Okay, you need 2. So per 1 molecule, for then the maximum number of what? The maximum number of the single bond that are there is what? 2. So per if you take the molecule, okay, if you take the molecule for example, okay, okay, so here it means that one molecule of the hydrocarbon contains a certain number of what? Hydrogen. Okay, so 1 molecule of the hydrocarbon, that is the hydrocarbon, contain a certain number, but 1 molecule of hydrocarbon, okay, consume 2 what? 2 moles, okay, of hydrogen gas. Okay, so therefore it means that to consume 2, that means we have consumed 4 hydrogen atoms. Okay, you have consumed 4 hydrogen atoms, and it means that if we can draw the compound to be this, okay, we can draw the compound to be this, okay, that this 1 molecule of the compound, this one contain a certain number of what? Double bond, okay, and here to consume 2, to convert this, okay, to a single bond like this, okay, to convert this to a single bond like this, then you need 2 hydrogens here, okay, you need here, and you need here in order to convert this to what? A single bond. And you also need here and this one in order to convert this to a single bond. In that case, 4 hydrogen atoms, you have converted 4 hydrogen atoms, which is 2 molecules. So in all, which means that because 2 hydrogen molecules have been consumed during the process of catalytic conversion, it means that 2 what? Double bond, okay, are inside. Okay, per 1 molecule of the compound, 2 double bonds are inside. So this is the number that is inside. Okay, this is the number that is inside. Now we can also use that to also find for the triple bond. We can also use that to find for the triple bond. Now it is the same information, or is the same information. So 2 is the same information. So for that we have 2 hydrogen what? We have 2 molecules of hydrogen gas. Now 2 molecules of hydrogen gas per what will it consume? In our information we said that 1 triple bond in a molecule, okay, always is consumed by, okay, 2 hydrogen gas. That's what we did the relation. And I said that what happened is that here the 2 okay hydrogen atoms will sit on top and 2 hydrogen atoms will sit down in order to clear the what? The triple bond to what? To a single bond, okay, to a single bond. So it means that because 4 hydrogen atoms has been consumed, that means that only 1 triple bond is inside the molecule. Very simple. That's only 1 triple bond is inside the molecule. But for double bond, it is 2. So this is the information. That's how to do the whole thing. All you need to know is to find the mole of the hydrogen gas that was consumed over the mole of the compound, and you divide. Once you divide the hydrogen gas versus the mole of this one consumed, then you can find per molecule of what the unsaturated hydrocarbon, per molecule of the unsaturated hydrocarbon, because when you divide you get a simplest ratio, that is 1 molecule of the hydrocarbon to the mole of the hydrogen gas that will be consumed. To the mole of hydrogen gas that will be consumed. Once you know the ratio, then you can say, okay, since 2 hydrogen gas was consumed, then it will roughly mean that this is the number of double bond or triple bond that will be inside. And so that will end our lesson for today. And in our next lectures, we'll take our time and look at the various classifications of organic compound. We are now going to enter the various classifications of organic compound. Thank you.
My level, I love it. It's maybe today I don't get nothing, but tomorrow I go get something.